Hello everyone. I want to start this video by talking about pizza. Imagine a situation where pizza exists only in Italy, and every time you want to have a slice, you need to go to Italy to have it. That sounds very expensive, very time taking, and just completely illogical in today's world, right? Doesn't it make a lot more sense that if you want to have pizza, why don't we open up a lot of pizza shops across the world so that we can have pizza in a much more convenient fashion? Well, this video isn't about pizzas at all, as you can see from the title. But the reason why I'm asking you to think about that is because that is how the content that we see on a day-to-day basis on websites is served. You see, it would be very weird if I open youtube.com and all the video traffic is sourced from the United States of America only, and not just United States of America, one particular data center in United States of America. So it makes sense to spread out the servers across the world and let everyone enjoy the content in a convenient manner. And that sort of network, this globally distributed network, is what we call a CDN. This is short for Content Delivery Network. So what kind of problem does this CDN solve for us? So as I just gave you an example, if a user like me is in India and if the content is in USA, getting this content will be a very long round trip. It will be very long and very time taking. So CDN solves exactly that problem. Actually, it solves two different problems. First is reducing latency. How does it reduce latency? Well, it makes sense, right? In terms of geographical distance, if I have some servers that are in India, if YouTube's servers are in India as well, somewhere in Mumbai, somewhere in Hyderabad, maybe, I will get content a lot faster. Let's say if I'm in New Delhi, making a request, having it reach to my server in Hyderabad would be much faster than somewhere in New York, right? So this helps in reducing latency. And not only that, it also helps in reducing load. Because now that you have a globally distributed network of many servers across, well, the globe, since it is a globally distributed network, your request will not go to just one server now. It will not point to a specific origin server only. It will point to the server that is closest to you. And if you're in, let's say, New Delhi, it will point to the server closest to you. If someone is in New York, it will point to the server closest to them. Same for the users in Tokyo, in Germany, anywhere around the world. All right. So in such a setup that uses a CDN, these are the two advantages that we typically see. These are very obvious benefits, right? How do they translate to a better experience? Well, if latency is reduced, it is a given that it will be more engaging for your users. And if it is more engaging, it will lead to a higher retention for a user. I mean, imagine an app like Instagram, and especially with the reels section on Instagram, it is so addictive. And why is that? Because the content delivery is extremely fast. It's like this. So whenever you scroll, the next video is practically completely loaded unless you have a very slow internet connection. So that makes it more engaging, which leads to you being retained on their platform for a longer amount of time, gives them more attention, gives them more revenue. And that's adding to the revenue, but reducing load is something that saves cost. Because if the load on each server is now less, you can provision cheaper servers which can handle a small or medium amount of traffic instead of a less number of servers which handle a huge amount of traffic with a very high RAM. Right. And this I dive into a little deeper in my lecture on scalability, so you can go check that out. You will be able to draw a connection between the two use cases. So then we have cost savings, and we also have less downtime because of reduced load. How will it lead to less downtime? Because now your traffic is spread out across many servers. A few number of servers are not burdened by the large number of requests, right? So it is very intuitive, right? That it leads to less downtime. Again, this is related to horizontal scaling, which is again talked about in the very first lecture in this playlist. So go check that out. This is horizontal scaling, and CDN, having a CDN is one way to achieve that. So this is the advantage that we have with respect to CDN. Next, I want to talk about how do these CDNs actually operate. Not exactly a very technical deep dive, but to give you a brief high level overview of how these things work. So what ends up happening is that these CDNs, they have their servers at different POPs. What are these POPs? POPs are what we call points of presence. So POPs are these network access points, and they are the ones your request goes to. These are the ones that ensure what we call accessibility. So if I'm in India, I will have a point of presence in Mumbai or Hyderabad or something like that. Somebody in USA will have it in New York, in Iowa, wherever the data centers are located, or basically any other locations. In Japan, it is in Tokyo, I think, for AWS at least. So this ensures accessibility, that wherever you are, you will have a point of presence near you that can ideally, potentially serve traffic for you. All right, this is what we have over here. So we have a lot of providers for these CDNs. What providers am I talking about? One of the most popular providers is Cloudflare. This is not an endorsement per se. I'm just really relaying my experience and the tools that I have used in my experience as a developer in production case scenarios. Cloudflare has been pretty evident over there, pretty much present in a lot of applications as a CDN provider. Then there is AWS's Amazon's CloudFront. There are a lot of other options as well, like Microsoft's Azure CDN. We have Akamai. We even have Google Cloud CDN. So there are many more options, no point in trying to list all of them out. But these are some of the providers that you can consider when you are building your own project. And depending on which other stacks you've used to build your project, you can choose your option. For example, if your databases and other things are provisioned via AWS, then maybe CloudFront may be a better choice. Same goes for any of the other providers, something like that. All right. So the next thing I want to talk about is how does a CDN calculate which POP should your request go to? So there are roughly two very popular ways of dealing with this. The first is DNS based routing. Now, if you have seen one of the previous videos in this playlist, in which I talk about what happens when a URL is entered into the browser, you will know exactly how this DNS based routing works. So that's one of the options. What it does is it calculates whichever POP is closest to you based on its own listing, and according to that it returns the relevant POP. We won't dive into the technical implementation of this, but this is one of the options for you to keep in mind, that this is what happens at the back end. And one thing to note here though is that each POP has a different IP address over here. All right, so the next option is what's called Anycast. This is also a very popular process used to basically calculate your POP, and this is just an algorithm used by your network to get the closest POP to you. Now, one thing to keep in mind again is that each POP has the same IP address now, and this is a point that we'll come back to later on in the video. So, for example, in DNS-based routing, if our POP is in New York and in Mumbai, the IP address will be different. One could have 0.0.0.1, just any IP address random, and one would have 0.0.0.2. But in any cast, each POP will assumed to have the same IP address, which will be, let's say, 0.0.0.1 all over the globe. So that is what the approach entails in this particular part. Moving on, I want to talk about POPs a little more. What actually happens inside those POPs? Well, not too many details, but what these POPs have are something called edge servers. This may be a term that you may have heard, especially if you're a computer science student or if you've studied cloud computing in one of your semesters in college. We have edge servers over here. So, POP, you can assume that this is like some building or a data center. And edge server is basically like your server, right? Your machine. This is what actually processes the request that you send to it. So this is what we have over here. Now, what is the role of this edge server? So this edge server, what it does and how it makes things faster is via a process called caching. So I've discussed the concept of caching in very heavy detail in, I think it was lecture 4 in this playlist. So go check that out and you'll understand exactly what happens in caching, what is its purpose, and then you'll be able to maybe make some connections in what our edge servers are trying to achieve over here. But I will go through this briefly so that you don't feel very out of touch in this video. So edge servers use caching. What they do is they cache a lot of content from the origin servers. So how does that flow work? So let's say this is you. All right, this is you. You make a request to the internet. All right, this is a badly drawn internet, and the internet returns to you the DNS of the website you're trying to access. This is something we've covered in the previous video. Then your browser basically establishes the connection over here. What does it establish the connection to? We have the IP address of the edge server now. All right, so now in every video, notice that we are adding more and more components to our overall flow, which simply involves making one request and getting one response, right? So in this flow, what we're adding is our edge server. Let's call it an E. And this edge server, now what it does, especially if you're calling it for the first time, it will make the request to the origin server. All right, it makes the request to the origin server, gets the response to it, performs caching over here itself. It caches this response temporarily for a certain amount of time only. Actually, that is depending on the strategy, which we will also discuss towards the end of this video. So it caches this data via some strategy and then it returns the response to the user. Now, this flow is good, but it gets even better when the user makes a request the next time. So when the user makes the request the next time, we already have the data at the edge server itself. It does not make a request to the origin server in this case. In this case, it simply returns the response from here itself. And this is what makes things faster. All right. So we have a lot of edge servers basically, and a lot of users calling these edge servers. And basically what this does is that it reduces the load on the origin server because most traffic is being handled by them instead of this origin server now. All right, that's how this caching process works for edge servers. Now, CDNs don't just cache data. What they also do is they add a layer of security. What they do is help in preventing DDoS attacks. How do they do that? Think about this Anycast example that we talked about over here. I said that we will come back to this point that each pub has the same IP. So whenever an attacker tries to make a load of requests, that's what a DDoS attack is, right? You make a lot of requests in order to crash the server. So we have the same IP over here spread across the globe. So assuming we have a load balancer in as part of our CDN, this request will now be spread out across many different IPs across the globe. And the idea is that our service has a lot more capacity to handle requests than the attackers who are actually making those requests. And so if our request is spread out across many servers across the globe, the chances of one or more of the servers crashing becomes very, very, very less. So it helps us in preventing security, DDoS attacks and adding security. It also helps in optimizations. How does it help in optimizations? It can minify files for us. For example, if you have a JavaScript file, it can minify it for you. So minified file is basically a compressed version of your usual JavaScript file that you write, which has only the necessary information. It does not have any comments, it doesn't have any extra spaces, paragraphs, nothing. It is just pure executable code. So it can simply cache that at its own level on its own as long as it is configured to do so. It even for images, it can use more modern formats like WebP. It can use .avif instead of your usual classic formats like PNG, JPEG. So it can perform some optimization on its own, and it can even help in preventing hardware failures. And we've already discussed this point in brief. So the way it helps in preventing hardware failures is that, well, the hardware may still actually fail, but the user will not feel it. Because let's say I'm a user, I'm making a request to my edge server in Mumbai, and for some reason, for any reason, this server crashes. What will happen next? My CDN can be configured to fetch my data from the next closest edge server, which could be, let's say, in Hyderabad. So basically, my access is still active. My experience is still very, very smooth. All right. So very minimal downtime offered via this mechanism. The next thing I want to discuss is types of CDNs. We're going to discuss two types over here. One of them is push-based CDNs. So what they do is whenever there is a change on the origin server, only then is the content updated on the edge servers. So let's say I have an origin server over here. I do git push on my main branch. Some deployment happens. My origin server is now updated. It will push changes to my various edge servers. All right. And that's the only time our edge server will be updated. Every time the user then asks for some content, it will directly send a response back from the edge server like this. All right. So in this manner, what happens is that the traffic to the origin server is very, very minimal because all the requests are going over here to the edge server. So the content stays cached on our edge server till it is updated again. So this is not the only way you can use a push CDN, but this is one of the ways to do so. Now this is good for smaller websites because these updates could be pretty heavy to communicate to each edge server, especially if it's deployed across the globe. So this is good for smaller websites and websites which don't have updates coming in as frequently. So that's where push CDN comes in. Next is the exact opposite, and by this time I'm sure you've guessed it. It is pull CDN. So pull CDNs, what they do is they update content only when the user requests for it. So we update content on our edge server when user requests. The advantages in this approach are that only the requested content is stored on the edge server. So if a user requested for a certain image from a website, only that is brought onto the edge server and cached. the other information is still present on the origin server only. So this makes it a good option for heavier websites, because now you don't have to transfer all the information to the edge server every time there is a change. So you can use this for bigger applications as well. One thing to note over here is that this uses something called a TTL, or a time to live, because caching is involved, right? So I've discussed this in the video on caching, that you can have a TTL when it comes to expiring content on your cache. Now, this is important because you have to invalidate it after a certain point in time anyway, right? So maybe let's say after 1 hour, you say that, okay, it's been 1 hour. So if there is a request after this 1 hour has elapsed, you request the content from the origin server once again. Now, this can be a redundant operation sometimes, not all the time, sometimes, because it is possible that the origin server has not changed at all. So there is still some traffic between the edge server and the origin server over here in this particular example. So that's full CDNs for us. That's all I wanted to cover when it comes to CDNs. In the next video, we'll cover another cool concept. So stay tuned and follow for more.